At Deloitte, we closely work with the semiconductor industry, helping clients strengthen supply chains, optimize manufacturing, and prepare for the ongoing growth in chip demand. As advanced node demand accelerates, especially with AI, the pressure on EUV tools and photomask quality continues to rise. Photomask inspection is already a billion-dollar market, and improvements in this area influence the global semiconductor sector that we expect will surpass $1 trillion in the next few years, a future where defect-free masks could become essential. And while the idea that semiconductor manufacturing could move into orbit might give pause to some, we recognize that the broader space ecosystem affects manufacturing, materials, data, and supply chains in ways that extend well beyond traditional missions. We see opportunities that can directly benefit Fortune 500 companies that currently have nothing to do with space. When we met Astrileux, we saw a company pushing the frontier of EUV photomasks and advanced chip components, leveraging the in-space environment to explore new ways of creating high-quality assets and redefining how chips are made. The Commercial Space Challenge offered us a chance to explore what happens if and when manufacturing shifts into orbit, what new economic models emerge, and how Deloitte can help map that space, literally and figuratively, between startup innovation and large-scale impact. Astrileux's work is deeply technical. It lives in the world of EUV, soft X-ray, metrology, and manufacturing, and what we brought to the table was the business context. Supply chain implications, market modeling, cost-benefit frameworks, and clarity on what must be true across the industry for this type of manufacturing to become feasible and profitable for end users. Together, we outlined new-to-market concepts for what orbital manufacturing value chain could look like, describing the foundational conditions and assumptions that would need to be validated as this frontier continues to evolve.
For me, one of the most exciting parts of this journey has been seeing innovation through the lens of collaboration. During the challenge, I worked closely with Astrileux, a startup exploring how the in-space environment could support the next generation of semiconductor manufacturing. And as someone whose work at Deloitte focuses on helping states, spaceports, government agencies, and other stakeholders really understand the role that they're going to play in the commercialization of space, I was thrilled to learn more about Astrileux's mission and help them with their goals for the challenge. So on the whole, I really think that this experience demonstrated the immense value of combining enterprise and startup perspectives. Together, we explored where space manufacturing might offer measurable advantages for EUV mask blanks, how in-orbit processes could affect yields or defect profiles on the masks, and really start to quantify the effect that in-space manufacture could have on the AI revolution. We also examined the end-to-end manufacturing process and looked at key considerations for value generation, things like cost of in-orbit production versus terrestrial methods, the capital investment needed for supporting infrastructure, which is always quite high when it comes to space, and the level of yield improvement required to truly make in-space deposition commercially viable. So through the challenge, Deloitte brought business acumen to Astrileux's groundbreaking ideas, and we closed the challenge with an actionable business plan and pitch-ready artifacts. To me, our work together really highlighted the possibility of space-enabled manufacturing, not just as an abstract idea, but as a subsector that's going to play a meaningful role in a market that's estimated to grow to $20 billion over the next decade. I'm sincerely grateful for the collaboration that we established with Astrileux during the Mass Challenge program, and I can't wait to see what Astrileux accomplishes next.
Astrileux, our goal is to help redefine how chips are made. We believe that leveraging space with its scientific environment can unlock manufacturing possibilities that are difficult to achieve on Earth. That's the vision behind in-orbit semiconductor manufacturing. We enjoyed working with Deloitte in the Commercial Space Challenge. They helped us pressure test that vision by exploring where in-space manufacture might provide advantages, how it could influence EUV photomask development, and what an orbital to terrestrial manufacturing connection could require. Deloitte also connected us into their broader space ecosystem, helping us sharpen our narrative and value proposition. Together, this work clarified the technical considerations, the economic thresholds, and the potential go-to market pathways. For us, the collaboration wasn't about presenting a finished model, it was about sharpening the early architecture of a new manufacturing approach and identifying the assumptions we need to validate next. It helped clarify which industries might benefit most, how the value chain could be structured, and what types of partners would eventually be needed. There's still more to explore, but this work gave us the structured starting point we can continue building on. Because orbit is no longer just a frontier, it's becoming a production environment. And this collaboration helped us take the first steps toward building a semiconductor ecosystem in space.